because we've used the derivative and we have found these zeros of the derivative, easy enough to find, we go over here and we can match up, and sure enough it's going to be there. Now the question is, what are the intervals of negative derivatives and positive derivatives? Well, again, if I look for a derivative between -1 and 0, it should be positive in value. Okay? And if I look for one between 0 and 1, it should be negative. And then over here would be negative and positive. So what we can do, and I can't remember now how your book presents this, so I'm going to give it to you in the way that I have in my notes, even though we've got the Inspire that could really help us out a lot. We're going to set up a table, and we're going to look at intervals. We're going to look at test values. It's a sign chart. I'll just put that up here. Sign table, sign chart. I don't know what name the book's using, but we'll call it that right now. We're going to look at the sign of the first derivative, and then we're going to have a line here for conclusion. Okay. So I've got now this, I've got on a continuum here, if I were to, let's pretend this is my number line, I could put down that, let's say this is -1, this is 0, and this is 1 over here. I've got my number line now divided up into 1, 2, 3, 4 intervals. I'm going to go from -infinity to -1. From -1 to 0, 0 to 1, and 1 to infinity. These are, you might want to make that note. Are these inputs or outputs? The interval. Are we inputs? You might want to put that in if you're not sure. These are input values here. Okay. I'm going to test a value in this interval. I can choose anything. Is it true that any input value less than -1 would have the same sign on the derivative? Doesn't have to be a special one. Anything I want. Any input value between -1 and 0 is going to have the same value or the same sign of the derivative. It should be positive, and so forth and so on. So all you have to do is just choose anything. So we can choose an x equaling -2, an x equaling -1/2, x equaling 1/2, and let's just say x equaling 2. We're just going to test out a get a test value, one for each of those intervals. What's the sign of our derivative going to be in each of those? Well, what I'm asking for is, if I put -2 into my derivative, let's see, where's my derivative? Negative 4x cubed minus 4x. If I put -2 in that, is my derivative going to be positive or negative? That's all I want to know. I don't need a specific answer. I just need to know, is it positive or is it negative? I could also put it in my factors here. So let's see, I like my factors better because if I put a negative, like a 4 times -2, and then a -2 squared minus 1, is my first factor going to be positive or negative? 4 times -2. Negative. -2 squared minus 1. Positive or negative? -2 squared. Positive minus 1. What's the sign of that? Now I need to get, you need to do that for you and then you come back later? Okay, we'll do it. What's the sign of a negative times a positive? It's a negative. So the first derivative is negative, my conclusion is that f of x is what? Increasing or decreasing? Decreasing. The first derivative is negative, so the function is decreasing. Is that what we said over here? Decreasing? Yeah, exactly what we said. So I'm going to go up here now, and I'm going to use, there are my factors. I'm going to use that the factors again with negative 1/2. So 4 times negative 1/2 is, 4 times negative 1/2, positive or negative? Negative. Negative 1/2 squared minus 1. Negative. Are you pleased? A negative times a negative is positive. Is that what we see over here? Yes. Okay, so we can choose any value we want. Now, I have to tell you, some of this work, like the sign chart, was extremely important to people like me when I was sitting in a place like you are. We had no calculator. We could not see a picture of this unless we did lots of points and then try to connect the dots in a reasonable manner. We couldn't just put it on a calculator and see a picture. And so it was really important that we had other ways of doing it. So the sign charts, a lot of good mathematics here, but the sign charts were extremely necessary to us. Are they as necessary to you? When you look at this, can you tell me where those are? You take the derivatives, can you look at this and see this is going to be negative and this is going to be positive? Yeah. So, you know, a question that we now have is, how much of this do I really hold you to? Well, I hold you to knowing the idea that if you have a positive and a negative, it's a negative and so forth. I hold you to the idea that you need to factor this out in order to find these, I'm going to call them this already. They're called critical numbers. That's going to come up later on, but these are critical numbers. X equals 0, x equals 1, and x equaling negative 1. Those are called critical numbers. So if I continue on, oh, by the way, if the first derivative is positive, what do you know about the function? Increasing, right? Second derivative, or the next one, if I put 1/2 in there, 4 times 1/2 is positive. 1/2 squared minus 1, negative. Are we surprised that it's negative? No. Is the function increasing or decreasing? Decreasing. Do we see that on the graph? Yeah, all this stuff follows the graph. So if you do a combination of this, you should not have any trouble with it. Let's do one more just to make sure the notes are complete. If I put 2 in, my test value 2, 4 times 2 is positive. 2 squared minus 1, positive. Is the function increasing? Yes. Okay, so the analytical work, and again, I show this to you because I can't remember what the problems on homework look like, but I want you to have this. I want you to know how that sign chart looks. They may have you do sign charts on some of those problems, so this is what we're talking about. Okay, always connecting it with what you know, what we see on the graph. Okay. Here we go. I knew it was coming up. I've done this lecture for the Calc 1 class. It's almost identical to this, but the way we say things in each class is a little different. So here's where you get the word critical number. Now I know the tendency is to want to write every single word down because you think the words are that important. They're not. It's the thought process we're going through. Critical number. Just remember that it's critical number. The function is defined at, is C an input or output? If f is defined at C, value C, input or output? Input, yes, an input. So if the function is defined at that input value C, then C is a critical number. There we go, critical number of the function if the first derivative is 0, and this is very important, if the first derivative is 0 or if it's undefined. Okay, if the first derivative turns out to be undefined, where it's undefined is also called a critical number. I don't know if you've seen many of those. In the other class we've seen them, but I don't know if we've seen very many undefined functions that have undefined derivatives. Okay. Guidelines.
So you're saying it's still a critical number?
Yes. Yes, it is a critical number. Let me just share with you that one of the ones, and I can't remember if we did that in this class or not, but if we have a function like this, we know that the absolute value function, we could see it, I guess. This value c, the derivative is undefined at that value c. The reason is, what's the sign of the slope of this portion? Negative. Okay, so the derivative as we approach c from this direction, the limit is negative. What is it on this one? Positive. You know, if you try to clap, you can't. Okay, so we say that the derivative is undefined because the limit does not exist at that point. And that's one of the reasons, one of the ways that the derivative is undefined. Okay, guidelines for applying. I want you to put all your pencils down. I don't want you to do this. If you want to know these notes, you can go back and find it, but this is too much writing for you to focus on that. Let's just listen for what we're doing here. Find the derivative. Did we do that? Yeah. Okay. Locate the critical numbers and use those numbers to determine the test intervals. Did we find critical numbers? How do we do that? Let me put it, I'll put it on here. Set the first derivative equal to 0. That's how we find and locate the critical numbers. Okay. Test the sign of the derivative at an arbitrary number in each of the test intervals. Did we do that? Back here. Remember I said use a test value. Anything that's in this interval, use it because it's true for all numbers in an interval. Okay, so we did a test value. And then use the test for increasing and decreasing functions to decide if the function is increasing and we did that. Okay, so all these words, you did it. Look at it later. It's in the textbook, but I don't want you to think. I don't want you to write that down. Okay, let's apply it. Find the critical numbers. Step 1. Take the derivative. What rule do we have to use? We're going to use that, but the first one we're going to use is, I heard it, product rule. Yeah, we have to. You got the product of x times the cube root. Now the first thing, actually the first thing I would do. Yeah, I'll stop that in just a minute here. First thing I'm going to do, instead of taking the derivative, I'm going to rewrite this as x times x minus 1 to the 1/3 power. I'm going to rewrite it that way because I know I'm going to have to use the 1/3 power. That's a cube root in case you couldn't see it back there. Okay, now I'm going to take the derivative and I am going to use the product rule. If you're not familiar with that, you need to be. So it is the first factor times the derivative with respect to x of the second factor plus the second factor times the derivative with respect to x of the first factor. So keep working.